Our marvelous Mother Earth, the most adorable gift God has ever given to mankind, the home for billions of varieties of life forms, undoubtedly the cradle of human life. Helios, the root cause of evolution and survival of innumerable species. HelioAstra, bridging the bondage between Helios and Mother Earth. HelioAstra is a great design of an advanced space solar power system. With the thoughts conceived in our minds, we have constructed the next generation power sat, HelioAstra, shining like a gifted sun for Earth. Having a close view over the integrated system of HelioAstra, we can observe the main base with embedded components like transponder, radiator, amplifiers, DC batteries, etc. The solid-state laser transmitter to pump high-power laser beam with reflector and gain antenna, and 4 huge solar arrays spanning over 1000 square meters of active surface area, exclusively designed to produce 1 megawatt of solar power. The saga of HelioAstra starts at Satish Dhawan Space Center, Sriharikota, India, amidst the dedicated engineers and scientists. Stands vertical, the launch vehicle, powering HelioAstra to change the face of technological innovation. 3, 2, 1. Here goes HelioAstra to create a new era in the history of mankind. With 3 stages, HelioAstra reaches geostationary orbit, the assigned destination, when the nation, or rather the whole world, applauds. After being projected into its distant orbit, the Dragon sprawls its wings. It flaps the 4 large solar arrays outside, shining like a star in the intense darkness. As apparent on the screen, we designed each HelioAstra solar array to contain 15 rectangular base structures of size 5 meters length and 3.12 meters breadth, and each bay weighing around 25 kg produces 16.7 kilowatts of power. Let's go deep into the details how this mighty object is going to energize the world. Looking at its microscopic level, the base structure forming the solar cells is the quantum dot doped on gallium arsenide solar cells. This small solar cell is made up of several layers. Highly doped N-type gallium arsenide substrate, 300 nanometers buffer N-type gallium arsenide layer, 50 nanometers of gallium arsenide layer, P-type gallium arsenide layer, and P-type aluminum gallium arsenide layer. Finally, it is covered by a blanket of Fresnel lens. As shown, this Fresnel lens highly focuses the sunlight onto one point known as focal point, where our solar cells are placed. When light is incident, the photons energize the electrons in gallium arsenide base in quantum dot. There exists a potential difference. The energized electrons excite and flow through the carbon composite structural tubes and produces DC current of electric power 760 kilowatt with generation efficiency of 0.76. All these tubes are connected to a single copper conductor to energize the solid-state laser diode after being stored in the battery. The neodymium-doped yttrium-helium diode is wound with copper conductor carrying the huge power generated by the 4 solar arrays. This diode is coated with silver on one side for reflection and partially coated on the other side for laser beam production. It contains huge number of free electrons that are excited with power supply. The red excited electrons move randomly and make collisions inside the diode with high velocity. These energized electrons try to come to their ground state. For that, they release energy in the form of lasers from the partially silver-coated side of the diode. This produced laser is amplified by the amplifiers inside the HelioAstra main base and produces 319.2 kilowatts of power. The laser beam shot toward Earth with transmission efficiency of 0.9 on the receiver located in the Bay of Bengal near Visakhapatnam, which receives a power of 278.3 kilowatt with power density of 0.75 milliwatts per square meter. The power delivered to Earth in the form of laser beam is captured by a disc-shaped concave or parabolic ground receiver antenna of 70 meters diameter. Again, here on the surface of receiver, high-efficient quantum dots doped solar cells are placed to capture the laser beam energy and to convert it into electricity. The produced electricity is used to energize the Earth-based seawater desalination plant based on reverse osmosis filtration technique. This plant is placed at suitable position to allow the inflow of saline water and outflow of desalinated water, and also to be convenient enough to receive the power supply. In our plant, we have designed 2 reverse osmosis chambers with membranes containing holes not more than 0.1 nanometer, through which the water flow with application of high pressure. With this, all the contaminants above the size of 300 daltons are removed and the purified water comes out. Along with the purified water, the brackish water containing all the contaminants is also released out. This water carries 98% of the velocity at the membrane. In order not to let this energy in vain, this water is redirected towards the initial cycle to rotate the wheel, which produces the pressure required. Thus, 60% of the energy is saved by this process. HelioAstra is technically plausible, economically feasible, and environmentally friendly alternative to the present scenario of energy crisis of fossil fuel depletion. We propose global collaboration in order to make this huge project successful.